So you got to find the intercepts for all the inequalities that are present. And so we got -4 and 2.5, so that gets you 1 mark. Okay, then we're going to rewrite it real quick. And this will give you 1 mark if you do this correctly. And because it's a finite decimal, it's okay to put it as a decimal. But other than that, I would like you to keep this y-intercept as a fraction, because you enter that into your calculator later on. And if it's 0.333 repeating, I want all those decimals in there when you find the points of intersection, right? Then you have the same answer as me. Okay, so if you have that, you get another mark. So that's two marks so far. And this is just for you, right? So this is a dashed line. True region is going to be above the line. And so we will shade below. Okay, so reverse shading is happening here. When it's a system, default reverse shading. It's just so much easier to find the solution region. For this inequality, it's already the way we want it, right? Both variables are on the left side. That's how I like it when I'm finding intercepts. Just makes it easier. These are them. You get a mark for that somewhere on that paper. Let's rewrite it, and here is going to be, right, this is actually going to be 2 marks coming up. So -3y is less than or equal to the 6x comes over negative plus 21. Divide everything by negative. That should be a warning right there that this has to flip the other side, which changes the shading, right? So this is actually 2x positive minus 7. We expected that. So we get you get 1 mark for rewriting it. So if you have the 2x minus 7, I would say you get 1 mark. But this inequality being flipped gets you another mark. So this is actually worth 2 here because of that. And then the last one, I'm just going to bring this y over to the other side. So it's 2y minus y is greater than or equal to 1. 2y minus y is just y. Like that. Oh, I'm not done yet. Let's go back here. It's a solid line. True region is above. You're gonna be having a different answer if you didn't flip. So as long as you're consistent, you can actually score. You lose that 1 mark, but if you're consistent after that, you can still score the rest of the marks. The only exception is if your mistake causes you to have like a lot less work to do, then I take more marks off. So if you have it like this, you get 1 mark for this one. And I know that this is a solid line. True region lies above. We will shade below. So far, we're out of 6 already. And then the fun part, the graphing part, right? Some of you are like, fun part? What do you consider fun? Anyways, here, x and y. And I'm just going to use the, don't you like the grid? So much easier to graph. I agree. But you need to be comfortable. This is dashed, right? So real quick, and it's a positive slope, which I expected. So just a check, and feel free to extend everything. Can I suggest something now that, as I'm thinking through it, it's probably better before you even put your pencil on this grid to first enter all of your inequalities, which is what I did, and kind of just have an idea, this is what it's supposed to look like, right? You don't know where the solution region is, but you do know where the border lines are. And then you're like, okay, this is what it's supposed to look like, so let's make sure that happens, right? And then the other one is 3.5, 0, -7, this is 4, 8, I go back here, 7, that's a solid. I'm not going to go as detailed as yours. I'm going to skip the labeling for me. But here's that line dashed, and then that's a horizontal line, the third one, right, at 1, which is dashed. And not always, sometimes the solution region is closed in on all sides, but not always. So don't always make that assumption. So now I'm going to start shading. So this first line, I told myself I'm going to shade below. So real quick, right, you do that. Some of your shading is just beautiful, right? So that's that. The other one is also below, right? So if this is your line, this would be considered below here. So that's out. It's out for every single inequality because, right, it's false for one, it doesn't work for the system. Then this one, the horizontal, I'm also shading below. So there it is, just quick. Right there. So your solution region is here. So that needs to be labeled. Half a mark off if that's not labeled. Half a mark off if any of the equations isn't labeled. Half a mark off if you did solid as opposed to dashed. Things like that, that's what I'm looking for. So 3 marks if you did this right, if everything is where it's supposed to be, everything is labeled, and I'm not done with it yet. I have to do the corner points, which I will actually walk you through just in case you're still a bit unsure. So in this particular circumstance, you have one here, the horizontal line meets the diagonal right here, and the other one is here. So you actually only have 2 corner points. This one doesn't count. It's the y-axis, right? This and this are the only corner points. So I'm going to go ahead and go second trace 5. And I'm on this one. That's the one I want to be. So I just hit enter. And then it jumps to this one. But I'm going to go arrow up one more time. And now it's on y3, which is, you can't really see that very well. Let's see there. Now I'm on the third line right there. So I'm going to hit enter and enter one more time. And so that intersection is negative 2.41. So you write that down. That's a full mark. 1 full mark for that guy. And then I have to find the one up here. That's between the 2 diagonals. So if you want to, go turn off y3. But I'm just going to leave it. It's too time consuming. Second trace 5. I'm on this diagonal. I'm just going to scroll to the side till I get a bit closer. Then you hit enter. And I need to, yeah, it jumped automatically to y2. So it's these 2 lines that I want to find the intersection for. Enter, enter. So it's 6.91, 6.82. Yeah. So there are the corner points. So 1 mark for each, right? Total of 2. 2, 3, 5, 6, 7, 8, 9, 10, 11. So this is, the whole thing is out of 11. I put 10 down, but I'm going to make this out of 11. So don't worry about the 17 at the top because that would have included the backside. Just make the whole thing out of 11. Yeah. Yes, half mark off for Mr. Dirksen. Let's take half a mark off. Thank you. Yes, yes, yes. My bad. That's an easy fix. Good thing it's an easy fix. Yeah. Any other questions? Yeah. Yeah. Yes, this one only has 2. It's this one and this one only. And I will explain. Those are the only 2 that where lines actually meet and that border your solution region. This one here is not bordering your solution region, right? Unfortunately, let's be nice today. Let's take half a mark off because you're still learning. Yeah, half a mark deduction for doing that. I know it's more work, but it's technically not correct. But on a test, I would take a full mark off because it's not your solution, right? It's in the shade, in the shaded region, so that cannot be. Points of intersection are surrounding your solution region. Yeah, and then coda. You forgot? Do you remember? Let me know. The graph is out of 3. Yeah. So it's the graph is. I can stop this. Well, no, maybe the graph is tricky because you're thinking, what am I getting marks for? But it's more like it's out of 3, and you may lose half mark here and there, right? I will never give you 0 unless it's obviously not there, right? If there's no graph, then of course you're not getting. But if you have something there and it's consistent, that's big. If it's consistent with what you did before, if you make a mistake up here, don't dread it too much. It's a nightmare to mark. This test takes a while to mark. But I have Desmos going all the time, and then I just type in what you have, and then I check and make sure you actually did the rest correctly, okay? Yeah, go ahead.